So good evening everyone. So welcome to this interactive session week 4 for the course on Introduction to Multimodal Urban Transportation Systems. So this course instructor is Dr. Arkopal Goswami from IIT Kharagpur and myself Suman Ganguly. I am a research scholar from IIT Kharagpur. So this week it will be a problem solving sessions unlike the other weeks because those were kind of theoretical concepts only. So here actually it consists of some problems, so maybe I will discuss, and as we go on discussing, so also I will ask you to solve it, or at least try to solve it after I will brief that how to do it, right? So let's start the session then. So this is like calculating average dwell time at any stops as well as the boarding area capacity and stop capacity, right? So these are this is the same data that is there in the course material itself. So as you can see, these are the inputs. So inputs are average boarding volume, so how many people are boarding the bus, right? And then how many people are alighting the bus, like per bus how many people. So this is and then the boarding door, how many doors are there, then the fare payment method and the boarding height, then the is stand is present or not, then the number of doors, available door channels. So some doors may have one or more channels, some doors may contain only one channel, right? So then percentage of boarders using the fare box. So fare box means who are actually paying the ticket in terms of giving the money, right? It's not like I have a card that I am showing to like we have metro cards, right? So it is not like a metro card, but the fare box we are using. So although in India we don't use this fare box, but it's a Western concept, but it is for the illustration purpose only, right? So then what is the door opening and closing time, then the number of loading areas. So at a if you have a bus stop, so there may be 2 3 4 berths or the loading areas, right? So what is the number of loading areas, then the fare payment types, right? So visual inspection, then the exact change is like it is related to the direct fare box, like some conductor is there, he is giving you the change after you give him the fare, it's like that. And visual inspection is like just checking the ticket, and it's like that, right? Or checking my card, it is like that. So then the alighting times are also there, front door, rear door, what is the alighting time, both those are difficult. So it's a sample values are there, right? So there are 4 bus stops and these are the inputs. So then start calculation, right? So these are the assumptions. So what are the assumptions? So 45% of the passengers use the fare box, and the assumption is that already it is given that if you see the last slide, so it is this 45%, right? This 45%. So if I can change it to highlighter, so this is 45%, right? So it is already given, but it is not given that which door it will use, right? So fare box we use only the front door channel and the first channel. So here the assumption is there are 2 doors, first or front door consists of 2 channels and the rear door consists of only 1 channel. So it is the assumption here. So and in case of fare box, the people who are using the fare box, they will use the front first channel, not the second one, front first channel. And no alighting is allowed to front door channel 1. So the channel 1 will be using for only boarding, front door channel 1 will be used for only boarding, right? And no boarding has been allowed in door channel 3. So door channel 3 will have no boarding. So it is only alighting the passengers. It is for. So there are 3 door channels and there are 2 doors. So the front door is having 2 channels and the rear door is having 1 channel. Front door, the 2 channels, the first channel will be for the boarding passengers using the fare box, right? Second channel, there could be boarding and alighting both, and in case of third channel or the last rear gate third channel, so it is for only the alighting of passengers, right? So it is written here. So then what is the percentage of people who are using the door channel 1, right, or boarding through the door channel 1? So then you know that there are 3 people total per bus. There are 3 people, those are boarding. It is the input that is given in the previous this thing, right? So for the particular stop 1, there are only 3 people who are boarding per bus, but we don't know that per channel how many people are actually boarding. We have no idea about regarding this, right? So then the 0.45 is, because I already mentioned that this many people who are using the fare box, they will only use the door 1. So 3 people and 0.45 is 1.35. This number of people actually will use, or this number of volume actually use the door channel 1, front gate channel 1, right? And then because in the third channel there is no alighting is allowed, so for boarding there are only 2 door channels, right, and both are front door 2 channels. So then the 3 minus 1.35 1.65 will be board through the channel number 2, right? So then alighting, so there is no alighting is allowed in channel 1, right? No alighting is allowed, only boarding purpose. So number 2 and number 3, those 2 channels will be used for the alighting purpose. And as you can go, if you can see the input, so alighting also in the case of stop 1 is 3, right? So we are calculating for first stop 1. So now if you can see uh, this channel 2, front door channel 2 will be used by both boarding and alighting passengers, whereas these 3 will be used for the alighting passengers. So naturally more number of people will alight through this channel number 3. So assumption is that 0.25% of the passengers or 25% of the passengers will use channel 2, right, for alighting purpose. So then it is 0.75 and 3 minus 0.75 is 2.25 who will alight through the channel 3. So as I am discussing, you can also ask questions if you have some doubt or if you are having some trouble understanding these things. So then what is the boarding and alighting number for all stops and per channel? So do you want to attempt and try to calculate? If I will always give you these inputs. See, this average volume per stop is 5. So can you calculate what will be the per channel boarding and alighting for the stop 2? Considering this boarding volume is 5 and alighting volume is 2, and we know that per channel, so this fare box will be used by the first front door first channel only, because this is for boarding purpose. And in case of alighting, we can assume that 25% will be allowed through the channel 2. So you can also try to calculate, as I will discuss also, right? So you can participate in this. So so these will be the number. So at least you calculate once and try to see whether your calculation is matching this or not. At least for maybe particular one stop, maybe stop 2, where boarding is how much? Boarding is 5, right? So boarding is 5 and alighting is 2. So at least you can try to see, because this 5, and if you multiply it with 5 into 0.45 through the first channel and front gate, then you will find that it will be 2.25. And as there are only 2 channels, as I mentioned, for the boarding, not 3, because number 3 there is no boarding, only alighting. So the total number is 5. So 5, if you deduct 2.25 from 5, then you will get 2.75. So these are the boarding numbers. So similarly for stop 3 you can calculate the boarding number. Similarly for stop 4 you can calculate the boarding number, right? So then in case of alighting also you can calculate similarly. So if I go to this is 2. For stop 2 it is only number of 2. So 2 into maybe 0.25, 2 into 0.25, the assumption is that 25% passengers will use the channel 2, as it is a shared channel using by both boarding and alighting passengers, right? So it is 0.5 and total is 2. So 1.5 will be using the channel 3, because there are 2 for boarding and 2 for alighting, but there are 3 number of channels. So I hope it is clear. You can calculate now for all these stops, right? So then that is there the number of volumes of boarding and alighting that we have discussed. So now the second point is how much time per passenger, what is the average boarding and alighting time, right, for a particular stop or maybe for all the stops also. So as we discussed, the boarding will be allowed for only channel 1. Channel 1 will consist of only boarding, not other things, right? And it will be exact fare boarding. So we will pay directly in the bus. So this exact change value, if I go to the input values, so this exact change value is 4.50 seconds per person, right? This is the fare payment method. This is the 45%. And it will be using the first channel only. So now if I say that it is 4.50 exact, that's the same value, right? 4.50 seconds on an average per person. So now what about channel 2? Channel 2, it will be visual inspection. Like if I have a green card, and conductor will just visually see if I have the card, I will just like this is the ticket, it's like that, right? So now this is the value 2 as is given in the input. So this is visual inspection is 2, right? So this is the 2 seconds per person. So now if we can go to the channel 2, but I have multiplied it with 1.2. So why this is 1.2? This is an arbitrary number 1.2, right? So this is showing that it will not be 2, it will be more than 2, because if there are 4 passengers suppose who are boarding and there are 2 passengers who are alighting at the same time using that particular door channel, that is number 2 in the front door. So there will be some more time will be consumed, because there are in between the alighting passengers. So it is a 1.2, this 20% is arbitrary number, but there will be something more, it will not be 2 but more than 2, right? So then what is the boarding on channel 3? Channel 3 has no boarding, right? So there is no boarding time also, right? So then alighting for channel 2, because channel 1 there is no alighting, only boarding, right? So channel 2 it's a mixed boarding and alighting. So now if I go to the input, so alighting time has been given, it is 2.50 seconds per person for front door, and for rear door it is 1.75, right? So now if we can go, okay, so this is 2.5 is for second channel. So I already mentioned that front door has having 2 channels. So this second channel is in the front door. So front door, the time is alighting time is per person average is 2.5. So here also again I have multiplied it 1.2 because of the boarding passengers only. So it may not be 1.2, I am just saying because it 1.2 is just a number. So we don't know exact number, but it will be more than 2.5. So it is, we have taken it as 3. But if some factors is given, you can consider it as 1.2. So then what is the channel 3? Because it is only for the purpose of alighting, nothing else. So it is 1.75, which is directly given in the following input, right? So now we know the volume as well as we know the time, right? So we can now calculate there what is the total time, right? Total passenger flow time for each channel, because we have calculated for each channel for a particular stop. So what about now, you can see what about our stop 2, 3 and 4. What about this stop 2, 3 and 4? So actually if you see, it is independent of the stops, right? So exact change, whatever the time it will take for stop 1, it will take the same time for stop 2 also, right? Because per passenger, we are not saying that volume won't change, volume will change, but the per passenger we are considering as the constant for all the stops. So these values won't change even if the stop number changes for this case, right? So now the passenger flow time, that is the volume multiplied with the time. Time means the boarding or alighting time. So for door channel 1, the boarding is 1.35 and the time is 4.50, right? Boarding was 0.45 into 3, right? That is 1.35 only. This is the volume and this is the time. And alighting is not allowed, right, for through door channel 1. So this is the total seconds, passenger flow time in seconds, right? It is in seconds. So then door channel 2 is having boarding as well as alighting, right? So then it is the boarding volume through door channel 2 for a stop 1, not for stop 2 and 3. So it is 1.65 as we have calculated, and this is 2.4. If you can go to the previous slide. Devesh Singh. Okay, should I? Okay, let me see. Okay, so you are saying that I should enter into that and then I will try to discuss, but it is not giving me the access, and also there are more participants will be there also, right? You can also speak if you want. No need to only message, because I think you can speak also. It is allowed here. I am not. Okay. No, if you have any difficulty or understanding difficulty, directly you can ask, because this is not for one-way speaking. It is for two-way communication, whether through the messages or through the audio, right? Okay. So what I have discussing that then okay. So this channel time 2, this is for 2 is this 2.4, right? The time is the boarding time. So as this boarding time is 2.4, so if I can go to the next slide, it is 2.4 and the volume is 1.65, right? And then the alighting time is 3 seconds, right, per person. So this is the volume 0.75 and the 3, and the total is 6.21 through door channel 2. And then for door channel 3, it is only alighting, no boarding, right? So boarding is 0, no volume, no time, right? So then in case of door channel 3, what will be the volume? The volume was, we calculated for stop 1 is 2.25, and previously this is 1.75, right? So we are using this 1.75. So now it is 3.94 seconds, it is 6.075 seconds, and it is 6.21 seconds for stop 1, right? So similarly we can calculate for stop 2, stop 3 and stop 4, since there are 4 stops, right? So it is what? It is the passenger flow time through each channel, right? So what is the max? So now our intention is to calculate the dwell time, right? So dwell time is what is the time that the particular bus or train that is stopping at a particular stop to serve the passengers, right? So this channel, if we have 3 channels, so simultaneously people are boarding as well as alighting, right? So if we add them, then it is not the dual time, right? It will be more than dual time because it is simultaneous process. So you should take the maximum of that channel thing. That's why we calculate channel wise. So if you have 2 channels, so one channel people are boarding and the other channel people are boarding and alighting, and other channel is people are only alighting, right? So whatever the maximum period is, so that period will be the period when the bus has to stop, right, for that particular period. So if your boarding ends like suppose your boarding ends like your boarding total is taken 5 seconds, but your alighting took maybe 9 seconds. So minimum for night time 9 seconds the bus has to stop, right? So that's why this maximum value has to be considered for calculation of dwell time. So then the next stop is passenger flow time for stop 2, 3 and 4, as I have already discussed that for passenger 2, 3 and 4. So see, this maximum passenger time you have to calculate. You have to calculate for each channel, then you have to see which channel is takes the maximum time. So here it is 10 point something, it is 20 point something, it is 12.6. So these things has to be considered when we calculate the dwell time. So now dwell time is not only this time but also some other times also, right? So this is the dwell time. So maximum passenger flow of all door channels, right? For and the boarding loss time. So there could be boarding loss time if there are multiple loading areas like 2, 3, 4 areas, then bus will take some time before boarding, and also if the surface is not level also there could be some kind of some seconds can be lost, right? So then also the time of door opening as well as closing, right? So that thing, if you add these 3 up, then you will get the average dwell time, right, for a particular stop, or if you add then for all the stops. So then for a particular stop at stop 1 it is 10.2. So how we get this 10.2? So this door opening and closing, so I am going back to our inputs. So this door opening and closing, this 4, right, for this stop 1 it is 4 seconds, and also the number of loading areas is 1, right, it is not more than 1. So there will not be any kind of boarding loss time, right? Boarding loss time will be 0. And we have already calculated our this is what? This is 6.25, the maximum for particular stop 1. So now you add your 6 point something, your 0 and your 4. So it will be 10.2, right? Similarly, we calculate for 2, 3 and 4, right? So then this is the dwell time scenario, 2, 3, 4, right? So you can easily calculate the average dwell time per stop, right? So then what is the loading area capacity? It is the next thing, right? So we calculated our dwell time, right? So what is the loading area capacity? What is the loading area? Loading area means if suppose this is the bus stop and these are the suppose 2 buses. So if these are the 2 bus berths, so these are the 2 loading areas also you can consider. So these are the 2 loading areas. So for each loading area there is a capacity, right? So what is this capacity? So capacity is defined as seconds in an hour available for the bus movements. So suppose it will be calculated per hour only, but just see. So generally what happened, so if you have a bus stop, so there will be either a intersection is nearby, right, or maybe bus stop if it is in the mid block, then also there will be intersection after certain distance. So for a particular stretch of road, if the green time or the whenever the signal is green, that time only bus is moving forward, right? Other time, in case of red time, bus is standstill at a particular location, right? Or close to the nearby to the signal. So only the seconds that are available for bus movements is the green time of a particular signal, right? So if you consider per hour scenario, so whatever the total cycle length is, so cycle length of a particular signal consists of green time as well as the red time. So red time is what? The time when the bus is stopped. So our signal, it is red and then it is green, right? So if we don't consider the amber time also, right? So we are not considering the yellow time here. So just if you can see that there are green times when the bus can pass, right? So based on that, the G by C ratio multiplied with the seconds, 1 hour, that is 3600 seconds. So this is the time per hour that is available for the bus movement. So this is this formula. And then the seconds that a bus occupies at the bus stops. So what is the time that the bus occupies at the stops? So this is TC. So what is TC then? It is the clearance loss time. So what is this clearing loss time means? So it is consist of startup loss time, then the delay. So suppose there is a bus stop here and the bus has already served the passengers, but there are certain vehicles, other vehicles, car, bikes and those things. So now bus is not immediately able to join the traffic, right? It is waiting here and then, because vehicles are coming like this and it is waiting. So whenever it is getting a chance or getting a gap, then it is joining or merging with the traffic, right? So then this is called the re-entry delay of the bus, because there are some lost time here. So it is the re-entry delay, right? So then what is queue service delay? So suppose nearby there is a signal. So there is this is the stop and this is the signal, suppose, and it is red. So there are many vehicles here. There are many vehicles. So after serving, so this is serving and there are vehicles which are waiting, right? So now bus has to the time the signal is red, bus will wait there, and then after also it will move. It cannot move to the free flow speed, right? It will move in the queue because there are vehicles are there, like in the downstream there are multiple vehicles. So it is called the queue service delay of the particular bus, right? So although you can argue that if signal is not there nearby, then it may not be there, but we are like suppose these are the possible things that may occur, right? But re-entry delay, it, because if the bus is traveling on the morning, then there will not be any re-entry delay. But if it is a peak hour or there are volumes are there, then it will re-entry delay also will be there, right? So then this is the startup loss time. So what is this startup loss time then? So if you analyze a particular signal in your intersection, so whenever the signal is red, then it is green, right? So during this red, the vehicles might be stopped, and maybe some vehicles also the engines will be like they will switch off their vehicles, right? So whenever there is a green, so it will take some more time to getting forward, right? So it will take some time, so those times, that time will be lost for the traffic in general, and because it is lost here and if bus is stopping here, so it is the same time that is also the faced by the bus, because if your traffic is not moving, also your bus is also stuck upstream somewhere, right? So though that is this startup loss time for the particular bus. So now if you see, so this is the clearance time that the bus is pending at a bus stop or nearby a bus stop due to the these kinds of intersection configurations, right? So then multiply with this TOM, adding with this TOM. What is TOM? It is the operating margin. So what is the operating margin? So it is, you can consider it is an additional thing. So whatever your dwell time is at a particular stop, suppose your dwell time is 5 seconds. So maybe 3 seconds will be added due to the some kind of expected scenario, obviously, but is not that it will happen, but it may happen, right? So suppose your bus, like suppose your passenger demand is fluctuating. So suppose one day the passengers are, number of passengers are 5 at a particular stop, and the next day at the particular stop the passengers is 6. So your dwell time will be high based on the boarding and alighting of the passenger. So there will be a variation. It is not a fixed value, your dwell time. It will also vary. So to count for that variation, and also sometimes if at a particular, that in that particular time, if there are multiple number of vehicles which is staggering at this particular stop. So suppose 1, 2 and 3 vehicles are there, then your bus is coming. So your bus will not be able to enter into this traffic, right? So it is called the bus failure rate also. So those things are accounted in the operating margin, plus your lost time plus your dwell time, right? Your dwell time is this and this and this. So this is the total time that a particular bus is occupies at a particular bus stops, right? And this is the available time. So this is the ratio. So ratio is what? Ratio is the loading area capacity. So what is the loading area capacity? So then also there is a problem which we will solve at the end regarding this bus area loading area capacity also. So first we just brief about also the bus stop capacity. So as you calculate the loading area design capacity, as I mentioned, so then also you can calculate what is the bus stop capacity. So a bus may be having 1 or 2 or 3 multiple number of loading areas. So then what is your effective loading area, right? So because there could be, as I mentioned, there could be multiple vehicles already are there in the stops. So based on that and based on the position of the bus, maybe you are having 2 areas for the stopping, but your bus stops at like in the middle portion or the center portion. So the following bus has no space so that he can enter, right? So he needs to wait. So based on that, if this effective loading area will be there. So is there a queue or is no queue? So if there is random arrival, so loading area will be 100%, and if it is not, then it will reduce, right? Your area, whatever the 2 area is, 2 into 0.75, 2 into 0.50, it is like that, it will be reduced. So then the traffic blockage adjustment factors is also there, right? So it is based on this expression. So this expression is nothing but because it is not a dedicated lane. So if the bus is running on a dedicated lane, so that these no vehicles are plying, only the bus, so that's a separate issue. But normally in India, buses is plying with other traffic modes, right? So this lane will having some certain capacity. So this is the capacity, CCL. This is CCL, means the curb lane. Generally our bus is stopping at the curb lane. So what is your curb lane capacity and what is the at particular time, what is the volume? So what is the maximum number of vehicles that can be passed at that particular lane, and what is the maximum number of volume that is there at a particular day or at a particular time, right? So this ratio multiplied with the F1 is depends on, because there could be locational influences also there. So if the stop is near side versus far side versus mid block, so there will be different effects. So based on this traffic adjustment factors is calculated, right? So if you multiply these 3 things, so you will get what is called as bus stop capacity. So now this is the thing you need to calculate. What here? Compute the operating margin of a bus stop given this coefficient of variation is 0.60, standard normal variable. For what I have already described, what is failure rate. I have already described that there will be passenger variation, so the dwell time will vary. So this is here, the CV is accounts for that, Z is accounts for that, and the average dwell time is 20. Then you need to calculate the operating margin. So I do not intend to do this because it's very easy, I already mentioned. So I want you people to, or like in the chat box you can calculate and then you can answer it. I will wait for you because already I have shown you the formula and it is simple thing. So operating margin is the additional time, right? I have discussed that due to the passenger variation and due to the multiple bus is already there, so bus is not actually having any space so that it can enter into the bus stop. So that is called bus stop failure, and the average dwell time. So it is something like something like some fraction of the average dwell time, right? So that's why the values are also less than 20, right? So can you just calculate, because it's easy, it's nothing but if you calculate, if you multiply 20 with 1.04 and 0.60, I think you will get. So what is the result? Tell me. So what is the result? I want you people to answer. I already discussed what is the operator margin. So in the chat box you just say that is it A or is it B or is it C or is it will be calculated. I have already like you don't need to consider this because I already told that it can be calculated and I already mentioned. So just can you calculate and tell me the answer? It will be what? CV into Z into our dual time, right? So what is CV? CV is 0.60, right? So what is Z? Z is 1.04, right? So what is dual time? It is 20. So it will come out to be this. Yes, Devash Singh, you are right. It will be B. So I think it is somewhat clear. So now we can go to the next problem. So this is for a bus transit service, compute the bus stop capacity. So what is the bus stop capacity? So it is the number of effective loading areas, right, into the loading area capacity as we calculated, as we told you that how to calculate it, and then the traffic block factor, right? So then we need to see what are the inputs are given. So traffic blockage adjustment factor is given, so no need to calculate, it is 0.90. So then effective loading area is given 1.75, we don't need to calculate, it is a standard value. So what we need to calculate is the capacity of the loading area, right? So how to calculate the capacity? Already there was a formula, right? So the formula is what? Formula is 3600 into G by C ratio. What is G by C ratio? That is green time by total cycle time ratio, right? Divided by what? Divided by our TC. TC is what? What is the loss time, right? So it is the clearance loss time. It is also given here, right? And then what is our average dwell time? It is also given. So average dwell time into G by C, right? And then finally is what is our operating margin, right? So we can go back to our formula. This is the formula, operating margin, and this is. So I think it is very straightforward to calculate. So you please calculate. You guys calculate and tell me the answer. Right? So this is the formula. 3600 into G by C. G by C is given. Your TC is given. Your TD is given. Your G by C is again given. Yet TOM is also given. Right. So tell me the capacity of loading area. So it is the loading area capacity. Right. So this is your problem. And everything is given. Just tell me the answer. then what will be our stop capacity per hour, right? So it is buses per hour. So I will be waiting for your answers. So just calculate. And I already mentioned that why these factors are important to calculate the bus stop capacity. It is account for the lost times due to signal and other things. It is the dual time and it is for the purpose, additional purpose, because of the congestion and all, so that the next following bus or train should not be delayed or should not be affected, or the schedule should not be merged. So just calculate and tell me. So is it 91, 92, 90 and 100? Tell me what is the answer. And if you have any difficulty to understanding, then you can ask. Otherwise, it is, I believe it is straightforward, so I think you will be able to answer it. And this is the formula. So then your G by C is 0.60, right? So then 3600 into 0.60 is how much? If I calculate it, so it is 2160. So this value is 2160. So then what is your 20 into G by C? G by C is what? 0.6. So then 12 plus TC, 12 plus 15 is your this, plus TC is this, so 37. So 2160 by 37, 2160 by 37. Right. Tell me the answer. So what is the bus stop capacity? Right. So this is the formula of bus stop capacity. Loading area design capacity, number of effective loading area, and then your traffic blockage adjustment factor. And this is your loading area capacity. So it will be 92. So let me go to the next question. You can calculate. It is simple. No, you will not face any problem. So now determine the total passenger travel time if access time both to and fro the station is equal to 15 minutes and the travel time on the transit line is 40 minutes. So total passenger time is what? Your travel time is 40 minutes and your access time both to and from is equal to 15 minutes. So it is very easy, right? So if you want to go from a particular place A to B, so then if your transit station is A dot and it will, like origin station is, transit station is A stop and it is B stop, and this is your office O office and this is your home, right? So then you will go from A to A dot, then take a bus, then you will travel till B point and then you will reach the office, right? So tell me what is the total time here? Is it 50? Is it 15? Is it 45? Is it 70? What is the time? It is easy, right, to calculate. Just tell me the answer. Tell me, it is easy. You can calculate also, like seeing it, you can calculate. It is not like a previous thing you need to use the calculator or something. You can directly calculate. So what about other people? Only one people answered. Are you not getting the point that home is if your house is situated in that point A, then you will go by walking or any mode or bicycle or something, and then you reach your transit station, then we will ride through transit station and reach the point B, and then also you can reach the B dot point, right, or the B point. It is B dot. So it is 70. All people are saying 70. So actually it is 70. It is nothing but if you add 15 minutes here, because to and from access, this is 15, this is 15, and this is 30, and then it is 40. So total is 70. So this is my part. So I think it will be helpful. Now you tell me whether you have any doubts. And also there are a lot of people who are joined late, so it is not possible to discuss everything. So if you have any doubts, you can ask. I will be happy to help you. Right. So today what we will discuss is the bus station related. What is the how to calculate the dwell time from the data, then how to calculate our operating capacity, then how to calculate the bus stop capacity, right, and then also the simple passenger travel time for the particular journey. So if you want anything to repeat, then also you can ask. I will try to, in a brief, I will try to repeat. So these are the things that we actually today discussed. So this is the data. Then I just gave some assumptions, because you need to do some assumptions before you calculate. Then how do you calculate the number of boarding people through different channels, and then the alighting also, and then what is the per person alighting time, then for the all stops what is the alighting volume, then what is the total passenger flow time, and then what are the other components of passenger flow time. For the dwell time, what are the other components. It is not the a passenger flow time, it is the maximum passenger flow time at a particular channel, right, and then your boarding loss time. So if there are any boarding loss time, so bus is stopped but people are not coming due to the level difference, or maybe due to the traffic or some other things, right. And then what is the door opening and closing time. So these are the things. Then we calculate the dwell time, right. And then we calculate the loading area capacity. Then we we discussed how to calculate the bus stop capacity. Then we actually solved it, that how to calculate the operating margin for a particular bus stop, and then what is the bus stop capacity, how it is calculated. Beforehand we need to calculate what is the block, like what is the other aspects of this, what is the available loading area, what is the loading area capacity, right. And then finally the total passenger time. So I think that is all from my side. You can ask any question if you want. You just unmute yourself and tell me the questions, or you can in the chat box also you can write if you have any doubts regarding this or regarding any content of the particular video. Or otherwise we will close the session. I know there are people who joined late, so you can ask if you want some clarification regarding something, some particular things, or if not, then I will close. So I will, okay. So Akash has responded. So if you people also respond, then only, okay. So actually try to join in the time, then actually you can actually ask, and you can if you have any doubt, you can ask also, right? Because after a time it is not possible to discuss everything. Some points which may be discussed. So okay, if you are you are not having any problems or any sort of doubts, so then we will, yes, thank you also for joining in, and we will meet in the next week for this interactive session again, right, for the week 5 course. And if you have any doubt also, you can prepare your questions and then you can ask also, right? So thank you.